Hello students. In the previous session, we were discussing about different methods for solving ordinary differential equations. And the first method we learned was Euler's method. So in Euler's method, suppose you have a differential equation of the form dy by dx is equal to f of xy, and it is being given that the value of y at x0, let x0 be the initial point, so let that value be y0. Okay, and we may have to find out the value of y at any other point, say y1 or y2 or y3 or any other point value of y you have to find out. This is the normal way of solving, and we may have to find the solution in that way. So the formula according to Euler's method was that we can find the value of y1 as y1 equal to y0 plus h into f of x0 y0. And what is h? H is the interval. And we have discussed that the h should be very small, and then only the solution, or when you find out the value of y1, it would be more approximate. It would be more accurate. Okay, so and also we had understood that this taking the value of f of x0 y0 is an approximation we have done. So with this approximation and taking the final values of h, then we can find out the value of y1, and with the known value of y1 we can find the value of y at another point. Suppose you have the initial value of x0 given at say 0, x0 is 0, then you can find the value of y at any point, say x equal to say 0.5, so you can find the value of y at 0.5. You can consider the h value to be 0.1, then you can find the value of y at 0.1, then y at 0.2, then y at 0.3, then y at 0.4. Like that you can finally end up finding the value of y at 0.5. So we have practiced problems doing accordingly. Okay, now we are going to slightly modify this Euler's method, and that method is called as Euler's modified method. And the modified method is more a better or a fair good approximation, because you can understand that instead of this f of x0, if you can take the mean value of f of x0 y0 and f of x1 y1, that would have been more better. So when we were discussing about the theory of Euler's method, we had discussed that it is quite little more good if we can replace that f of x0 y0 with f of a mean value of f of x0 y0 and f of x1 y1. So then I'm going to modify this formula as can find the value of y1 using the formula y0 plus h into mean value of f of x0 y0 and f of x, say x1 and y1. Then you can get confused here also. You're going to find the value of y1, and when you write here y1, that will be not a easy thing to follow, but then y1 is actually the zeroth approximation of this y1, and here it is the first approximation. I can say, let me call it as the first approximation, and this is the zeroth approximation, and the mean value of these. So mean value of these means I'll put a by 2 here. Okay, so this is the modified method according to the based on Euler's method, and this is also called as Heun's method, H-E-U-N-S. So this is also called as Heun's method, and this is a fairly good approximation, better than the Euler's method for solving this differential equation. And here So let me say that, so I said that this is the zeroth approximation. And how do you make the zeroth approximation? The zeroth approximation is made by Euler's method itself, because y1, the first approximation of y1, that or zeroth approximation y10 can be written as y0 plus h into f of x0 y0. So with this approximation of y1, then using this function values, then you can find out the value of y1, a better approximation. Then you can, using this y1 you can find the better value for y1, that is second approximation. And then when you find out, going on finding the values, when it becomes more when the y1 values becomes more converging, or the values becomes very similar, then you can stop there and find the value of y1, or finally end up the final solution for y1. So that is how we find out the solution in the Euler's modified method. Okay, so here you understood that y1, the first approximation is this one. Okay, and similarly you know what x1 is. X1 is basically x0 plus h, the interval h. Okay, so now let's say the same Euler's modified method is being used, or it is the same thing is also called as second order Runge Kutta method. So the basically second order Runge Kutta method is Euler's modified method itself, but then there will be a little modification in the way we present that. That is only the difference. Basically, whatever happening within the formula or whatever happening in the calculation is exactly the same. But then when you write that in a, normally we represent the Runge Kutta method in a different form. So now I'll just show you. So I am going to write the second order Runge Kutta method. So in this method, I am going to once more write this, that is y1 is equal to y0 plus h by 2 into f of x0 y0, let me call for the easiness as f0, plus h into, sorry, f of h f0 plus, that is f at x0 y0. Then the other one is f at x0 plus h, then y1, right? So then this is x1 and this is y1, and that y1 is what? That y1 is y0 plus h into f of x0, and f of x0 I have written here as f0, so that is f0. Okay, so this is basically the Euler's modified method itself. Remember, here we had written the average of the two functions, one at f of x0 y0, and that is what I have called here as f of 0, and here f of x1 is x0 plus h, and then y1 is y0 plus h into f of x0 y0, and that is f0. Okay, so I hope you understood how I wrote the second order Runge Kutta method from the Euler's modified method, simply replacing x1 with x0 plus h and y1 with y0 plus h into f0. Okay. So now here I'm going to make another assumption, that let me call this h into f0 as k1, h into f0 as k1, and here also I am going to write h into f of this part. This h into f0 was taken as k1, then h into this part, that is f of x0 plus h into y0 plus, what is h into f0? H into f0 is k1, so y0 plus k1. Okay, let me call this as k2. So I'm finally, how will I write? I'll write as y1 equal to y0 plus h is taken care in case k1 and k2. So 1 by 2 into, okay, h into f0 is k1, h into this part is k2. So let me write it as k1 plus k2. Okay, so this is how we represent the second order Runge Kutta method. According to this, you can find if you have the initial value y0 and the initial x0, then you can find the value of y at some other point, say point 1 or point 2 or point 3 or whatever it be. You can find the value of y at another point according to the relation y0 plus half into k1 plus k2, where k is h into f of 0, that is f of x0 y0, and k2 is h into f of x0 plus h y0 plus k1. Okay, so now substituting these values, we can find the value of y1. So this is second order Runge Kutta method. Now we will, in the next video, we will try to solve a problem using this formula. So we'll find a solution for a given differential equation. Okay, thank you very much. So if you have any queries, please put it in the comment box so we can address that. So thank you very much.